There is a sea that is dying from within. Below 150 meters of depth, there is no oxygen, no movement, no life. Only darkness, saturated with hydrogen sulfide and geological silence that has lasted for millennia. But in the narrow strip where life still resists, something happens that science has taken decades to begin to understand. An invisible battle between creatures that have existed for millions of years and forces that none of them have ever faced before. The Black Sea is not just a sea. It is the largest anaerobic archive on the planet, and its secrets are about to be revealed. Wedged between 6 nations and separated from the Mediterranean by the narrow corridor of the Bosphorus, the Black Sea occupies 436,000 square kilometers of water that harbors an anomaly unique on Earth. Its surface waters, fed by giant rivers like the Danube, the Dnieper, and the Don, are relatively cold and rich in nutrients. A living layer that floats above a toxic abyss of hydrogen sulfide without ever mixing with it. The Danube Delta, in the far northwest, pours tons of sediment, nutrients, and history into its shallow margins every hour, creating one of the densest and most vulnerable ecological mosaics in Europe. It is here, on this permanent frontier between life and chemical death, that our story begins. On the rocky shores where the Danube Delta meets the Black Sea, among stones covered in algae and currents that change direction 3 times a day, lives a fish that appears to have been sculpted by a disturbed artist. The peacock blenny, Salaria pavo, does not swim to escape. It stays, it confronts, it dominates every square centimeter of wet rock as if the entire ocean depended on this possession. With bulging eyes that rotate independently of each other and a dorsal crest that rises like a flag on days of territorial dispute, this fish of only 30 centimeters commands a micro-kingdom with a ferocity disproportionate to its size. The males guard the spawning sites with a dedication that would shame many larger predators, fanning the eggs with their pectoral fins for weeks without interruption and without feeding. The female chooses her partner by strict criteria: the best defended nest, the most imposing crest, the most absolutely unshakable posture before any intruder. During low tide hours, when the stones emerge and the sun warms the coastal rock pools, the peacock blenny reveals a behavior extraordinarily rare among fish. It leaves the water. It walks on wet rocks, breathes through its cutaneous tegument, and inspects the territory as if the sea were merely one of its available options. In this world of liquid boundaries and unstable identities, the line between the possible and the impossible is thinner than any zoology textbook would suggest. Buried up to its eyes in the sandy bottom, completely motionless, an architecture of death contemplates the world from below with a patience that defies any human definition of time. The Atlantic stargazer, Uranoscopus scabber, is probably the most dangerous fish that no diver can identify before stepping on it. And that is precisely the point. With eyes positioned on top of the skull at an almost vertical angle, it sees everything that passes above without revealing absolutely anything of its presence to the world below. A fleshy lure that protrudes from its tongue imitates the precise movement of a wounded worm in the current, attracting prey that believes it has found an easy meal and finds the absolute opposite. The strike lasts less than 1/100th of a second, faster than any conventional film camera can record without extreme slow motion. Beyond its powerful jaws, the Atlantic stargazer carries pectoral spines connected to venom glands, placing it among the few venomous fish documented in the Black Sea. Its flattened body, sandy coloration, and absolute stillness are the perfection of camouflage elevated to the state of evolutionary art. Beneath the tranquil surface of any sandy bottom along this coast, there are ambush architectures that no inattentive eye will ever perceive in time. There are predators that need no speed, no pursuit, and nothing but patience and a light in the dark. The monkfish, Lophius piscatorius, is a wading machine with a nightmare body, a mouth that represents almost half its total length, rows of teeth curved inward like living hooks, and a bioluminescent appendage on top of its head that functions as a beacon on bottomless nights. In the Black Sea, this predator can reach 1.5 meters in length and weigh more than 20 kilograms, positioning itself on bottoms between 50 and 200 meters deep, exactly in the transition zone between oxygenated waters and the anaerobic abyss. At 3 in the morning, when the water temperature drops to 9 degrees Celsius and visibility falls to 0, the monkfish lights its lure. The bioluminescent filament oscillates with movements that perfectly imitate a wounded worm in the dark current. And when a young flounder approaches within 10 centimeters, the lower jaw drops 90 degrees, the buccal chamber expands to 6 times its normal volume in less than 6 milliseconds, and the negative pressure generated sucks the entire prey in before any muscular reflex can react. The bioluminescence goes out. The bottom returns to absolute silence as if nothing had happened. And this scene repeats itself hundreds of times a night along the entire coast, completely invisible, completely fundamental to the balance of everything that exists above it. The muddy bottom of the Black Sea's sheltered bays conceals an invisible blanket that sustains an entire chain of life without ever appearing in photographs or superficial documentaries. eelgrass, Zostera marina, a true flowering plant, an angiosperm that colonized the sea more than 100 million years ago, not an alga as the inattentive eye would suppose. Forms submerged meadows up to 2 meters tall where dozens of species simultaneously find nursery, food, and protection. Its long, thin leaves create channels of gentle current that oxygenate the sediment below, transforming potentially dead bottoms into environments of extremely high ecological complexity. The long-snouted seahorse, Hippocampus guttulatus, with its head crown as unique as a fingerprint, lives coiled around eelgrass leaves with its prehensile tail, camouflaged with such perfection that researchers need months of diving to estimate minimum populations. The males of this species carry their young in a specialized abdominal pouch, a male pregnancy that can produce up to 200 offspring in a single reproductive event documented in the Black Sea. But the eelgrass meadows are shrinking. Eutrophication, vessel anchors, and increasing turbidity are fragmenting these invisible forests into ever smaller and more isolated islands. What is lost with each square meter of eelgrass is not merely a plant. It is an entire architecture of dependencies that took millennia to assemble and for which no reconstruction timeline is known. In the shallow waters where the eelgrass yields to bare sediment, among the rock shrimp, Palamon elegans, pulsing in groups of hundreds of translucent individuals over the bottom, a flat, silent shadow begins to approach from the edge of the visual field. The common stingray, Dasyathes pastinaca, glides over the bottom with the undulation of cartilaginous wings that looks more like dance than hunting. 2.5 meters of wingspan, moving with an economy of energy that no human-made engine has ever replicated. When it enters the shrimp zone, the reaction is an explosion of transparency. Dozens of Palamon elegans fire in opposite directions under tail propulsion, creating a cloud of near-invisible bodies that confuses any predator with frontal vision. Those that do not escape vanish into the precise suction of the stingray's ventral mouth, without struggle, without sound, without record. The stingray's dorsal surface is the exact color of the sediment it inhabits, while its ventral face is white as chalk, a dichromy that renders it invisible both from above and below simultaneously. The caudal spine, with bilateral serration and integrated venom glands, is used exclusively in defense, a reactive weapon that evolution built for an animal that has never needed to attack in order to feed. The stingray did not learn to survive. It was born already being the answer. There is a fish in the Black Sea that begins life like any other, symmetrical, balanced, with one eye on each side, and then decides, within a matter of weeks, to become something else entirely. The Black Sea turbot, Scophthalamus meioticus, spends its first days as a pelagic larva in the water column. Then something extraordinary and irreversible happens. One of its eyes migrates. Mediated by thyroid hormones and regulated by genes that science is still mapping with precision, this post-larval metamorphosis moves the left eye literally through the skull until it is positioned alongside the right eye, while the entire body progressively flattens into a new and asymmetrical geometry. The result is a benthic predator that sees the world with two eyes facing upward from a body lying horizontally on the bottom. An evolutionary engineering solution that seems absurd until the moment one grasps its absolute efficiency. The Black Sea turbot can weigh up to 6 kilograms, and its flesh is the most prized among all fish along this coast, which has made this animal the target of fishing pressure that has reduced its populations to a fraction of what they were in the last century. Each captured turbot represents years of slow growth, an extraordinary metamorphosis, and an ecological role that will not quickly be filled by anyone. In the colder waters of the Black Sea, where the temperature rarely exceeds 12 degrees Celsius and the pressure begins to make itself felt in the ears, a shark circulates in dense schools that existed before the mountains that today surround this sea, before the Carpathians, before the Balkans, before any human boundary that can be named. The spiny dogfish, Squalus acanthius, is simultaneously one of the most abundant and most threatened sharks on the planet, a contradiction that says more about humanity than about the animal. With two venomous spines positioned in front of each dorsal fin and a slender body of 1 meter and 20 centimeters, this shark is proof that evolution needs no grandeur to be definitive. Its gestation lasts between 18 and 24 months, the longest of any known non-mammalian vertebrate, and each female produces between 2 and 11 live-born, fully formed pups per cycle. This slow reproductive rhythm has made the spiny dogfish catastrophically vulnerable to overfishing. Populations take decades to recover from a single season of poorly regulated intensive fishing. In the Black Sea, where this shark is caught both intentionally and as discarded bycatch, the schools have shrunk in ways that older fishermen describe with a mixture of nostalgia and disbelief that no statistic can translate with equal weight. In 1982, the ballast tanks of a cargo ship discharged into the Black Sea something that no international treaty, no navigation law, and no ecologist of the time could have predicted in its real consequences. The invasive comb jelly, Monimiopsis leidii, a gelatinous creature of 10 centimeters originating from the east coast of North America, found in the Black Sea a paradise without natural predators and with unlimited zooplankton abundance. In less than a decade, its total biomass in the Black Sea exceeded 900 million tons, a number that the scientists who first measured it repeated aloud several times before publishing, out of sheer disbelief. This translucent creature, which produces blue-green bioluminescence when disturbed and reproduces both sexually and asexually as conditions demand, consumed the zooplankton that fed the commercial fish and collapsed the anchovy and sprat fisheries that had sustained entire economies around the sea. The collapse cascaded up and down the chain. Fewer fish meant less food for the pygmy cormorant, fewer prey for the spiny dogfish, less balance throughout the food web that took millennia to weave. Menimiopsis leadui is not malevolent. It is simply competent in an environment where nothing evolved to contain it. And this distinction is the most disturbing of all. In the shallow waters where the Danube Delta dissolves into the Black Sea, among reeds, channels, and mud banks that change shape with each season, as if the delta itself were breathing, a bird dives like a black stone hurled by the wind and surfaces with its neck raised and a gleaming fish between its bill. The pygmy cormorant, Phalacrocorax pygmaeus, is the world's smallest cormorant, a bird of only 46 centimeters distributed from the Black Sea basin to the eastern Mediterranean and the Middle East, with the Danube Delta as one of its most important and densely occupied nesting sites on the planet. Unlike its larger relatives, this cormorant dives in waters as shallow as less than 1 meter, capturing small fish with an agility that seems physically impossible for such a compact body with feathers that are not fully waterproofed, a characteristic that reduces buoyancy and facilitates high-speed vertical dives, transforming an apparent disadvantage into a precise tool. After each fishing session, it perches with wings spread in a crucifix position, drying its plumage in the sun in a pose that local fishermen of the Delta have observed for generations and that nature photographers pursue with equal insistence. In the months of March and April, colonies of up to 300 pairs nest together in acacias and willows over the water, building stick nests that they reuse and expand each year. An accumulated architecture of fidelity to a place that, like so many others in this sea, carries no guarantee of permanence. The Black Sea has already survived a catastrophe that few seas have known. According to the widely debated Ryan and Pittman hypothesis, formulated in 1997 and supported by growing sedimentary evidence, approximately 7,600 years ago, what was a freshwater lake was flooded by the Mediterranean through the Bosphorus in an event of geological scale that forever transformed the chemistry and ecology of this enclosed basin. The life that existed here adapted or disappeared, and what emerged from this transformation was the singular ecosystem we document today. With its permanent anoxic zone, its species of exceptional tolerance, and its biodiversity, built upon the constant frontier between the possible and the impossible. The life that existed here adapted or disappeared, and what emerged from this transformation was the singular ecosystem we document today. With its permanent anoxic zone, its species of exceptional tolerance, and its biodiversity built upon the constant frontier between the possible and the impossible. But the Black Sea is changing again, this time in decades rather than centuries. The Anoxic zone is physically rising, compressing the habitable strip of life with measurable pressure every year. Eutrophication, caused by the fertilizers that the great rivers carry from European agriculture, feeds algal blooms that consume oxygen as they decompose, accelerating a process that geology would take millennia to produce on its own. And each species that has traversed this story, the peacock blenny that walks on rocks, the monkfish that lights its lantern in the dark, the stingray that dances over the sediment, the turbot that rewrites its own anatomy, the spiny dogfish that carries 300 million years of history in each spine, the seahorse that coils its tail around the shrinking eelgrass, the translucent shrimp that explodes in flight, the comb jelly that arrived uninvited and stayed without being removed, the pygmy cormorant that dries its wings in the sun above a delta that changes with each season. All these creatures exist within a window of time that is measurably narrowing. The question is not whether the Black Sea has the capacity for resilience. It has already proved that it does. The question is whether we will be the disturbance from which no recovery is possible, or whether we will choose this time to be something else.